In this video we're going to go over how to solve trigonometric equations using sine and cosine graphs as well as tangent graphs, and using cast diagrams with right angled triangles to help. So if we start off with the examples, we can easily use the inverse sine to figure out theta, but usually there's more than one answer, and that's what we want to try and work out. So if we use inverse sine 0.75, we've got our first solution. But usually there's more than one solution, so if we look at the sine graph and we mark 48.59, then that's about here. And if we draw a horizontal line, we can see it also hits the graph again at a different spot. We don't know what this is yet, and we always look at the range. It's 0 to 180, so we know it means within this range. So to find out the other angle, we can use the symmetry of the graph. So it's 48.59 this way, which means the other angle is 180 minus 48.59. So if we work that out, our other angle is 131.4. We can always check by putting it back in and seeing that we get 0.75, which is correct. If we do it for the next one, so tangent, we can use the inverse. To get 54.46. The thing about the tangent graph, it's not shown above, but it's very easy to get to the next one because there's a jump of 180 between them all. These dotted lines, these are asymptotes, and this goes on forever. So to get to the next angle, we can just add 180. Check to confirm. 1.4. So with the cosine, we have a squared, so this one's a little bit more complex. But if we get it in terms of cosine, then if we square root, with a square root you can always get positive or negative values, so we have to take that into account. This means we have to inverse cosine positive 0.5 and negative 0.5, so we could have many answers. So if we do positive 0.5 first, we get 60. Now we could use, to get the other angles, we could use the cosine graph, just how we use the sine graph. So if we draw our angle and then dot along and find the other ones to see how to get it. We could also use the cast diagram. So how we use this is you draw the angle if it's between 0 and 90. So let's say 60 degrees is about here. Right? And we have a cosine region. So we basically want to get the angle in the cosine region. And since the range is between 0 and 360, we know that we're going clockwise because it's positive, right? So to get it, we basically use symmetry as if it was reflected on that line. So 60 this way means 360 that way. So we can use our other angle is 300. we can check that. Yep. Positive 0.5. Now for the negative 0.5, the first angle is 120, and we can use the graph. So we have one angle which is 120, which is about here. It's an estimate. And now we want to use, we know that it hits the graph again, so we want to use this symmetry to get this angle, right? So 120 this way. So you can use the fact that they both start at the same height. This is 1. So 120 this way means 120 this way. So you can do 360 minus 120 to get there, which is 240. So just check again. Yep, negative 0.5, which is, they're all of our answers in that range. Next. So these problems require a little bit of manipulation before you can solve them, but it's basically the same principle. So we have sine and cosine. One of the relations that are quite helpful is tangent equals sine over cosine. Okay, so if we divide both sides by cosine, we have, right? As long as you're doing it to both sides, then it's still equal. So cosine divided by cosine is 1, and sine over cosine gives you tangent. So 5 tan equals 4. You get tangent by itself, and then we have it. We use inverse. To get our answer of 23.96, and then to find the others, because it's tangent, we can add 180. Is that the last one? Yes, it is, because 383 is above our range, so those are the two answers. For the next one, tan squared minus 2 tan equals 0. For this one, we want to factorise, because they both have factors of tan. So tan right, you've just pulled tan out of both of those variables. You can multiply out and you get the same answer. So we want to look for values of theta where it would make this equal to 0, right? Within the region of 0 and 360. So we have tan theta must equal 0, or tan theta minus 2 equals 0. So we'll start with this one. 0. Because it's tangent, we can add 180. Is that the last one? 360. Do you see how the angle sign? It's also including 2. So 360 is an answer. With this side, we have tan theta equals 2. Now if we try and take the inverse, we have theta equals 63.43. Then we find other answers. Is that the last one? Yes, it is, because it's out of the range. For this one, 4 sine theta squared plus 4 sine theta minus 3 equals 0. So this might look familiar in that you have a squared term, a constant. So it's similar to as if it was a quadratic, right? So we can treat it like that. You can either factorise it or complete the square quadratic formula, whatever, as long as you have sine theta equals something. Because I'm lazy, I'm going to use the calculator and we can solve it. So we put in the constants. So we have sine theta equals 0.5 and sine theta equals negative 1.5. So we can use this to now figure out values of theta. So using the inverse, 0.5, 30. Now I'll draw the graph again, or you can use the cast diagram. So we have 90, 180, 270, 360. So with sine, it's in 30 degrees, and we want it between 0 and 360, so if we draw a line, 30 degrees in, from 180, 30 degrees left, so 180 minus 30 gives you 150, and that's the other value. You can see how it stoops into the negative, so we know that there's no other positive value for this within those ranges. If we look at the other one, if we do sine to the negative 1, negative 1.5, we get an error because the sine only exists between 1 and negative 1. So negative 1.5, there's no value of theta. So those two are our answers. With these can be solved without a calculator. But as long as you have the two triangles that you need, it's easy if you remember them, but you may be given them. So you have 60, 30, root 3, 2, 1. And you also have 45, 45. These are right angles, by the way. Then you have 1, 1, root 2. And so we can solve these just by looking at these two triangles. So we have sine 45, we have angle 45. Remember, sine is opposite over hypotenuse, so opposite over hypotenuse. So sine 45 should equal 1 over root 2, and that's right. We'll just check. Yep, root 2 over 2. If we rationalise this denominator, 2 over root 2. Yep. So sine 30 of sine here, opposite over hypotenuse, sine 30 is 1 over 2. Cos 60, cosine is adjacent over hypotenuse, so we have 1 over 2. Tan 45, so tangent is opposite over adjacent, so we have opposite over adjacent, which is 1. Sine 60, so sine is opposite over hypotenuse, so opposite over hypotenuse, root 3 over 2. Cosine 45, cosine is adjacent over hypotenuse, so it's 1 over root 2, which can be rationalised like sine 45. And that's it.